My name is Jim Walker. I'm the facilities engineer at Hutchinson Cancer Center in Seattle. We've been excited to do a lot of the cutting edge projects. It's fun to do some of the projects that no one else is doing, such as water reuse projects, where we're using relatively clean wastewater a second time before we throw it away. We had a common drain system up in our glass washer area. And this is where we wash our glassware for the laboratories. And so we isolated the hot drain from the cold drains, and so we ran all of the hot drain over here, and we go through a pair of basket strainers to get rid of any materials. The basket strainers are right here. There's those two black devices between those four valves with the red handles. And this water is just flowing by gravity. You see right here, the heat recovery hot wastewater. So this water flows through, and what we have right here is you'll see a shell and tube heat exchanger. So the hot wastewater coming through, say anywhere from 130 to 160 degree Fahrenheit, goes through the shell side of the shell and tube heat exchanger and gives up its heat. The city water goes through the tubes in the shell and tube heat exchanger and picks up this heat, and then it goes back to our system. Now where it goes back to is the water supply just ahead of our gas water heaters. This project is about 7 years old, so it's been working very well for 7 years. This is actually one of two locations. We do this under our glass washers and under another washer process. We save about 1,500 gallons of city water, as I said, but we're also saving a lot of natural gas on the preheating that we don't have to do with the water heater. So when you combine them, it's about $50,000 a year that we're saving in both water, sewer, and natural gas costs. So about 7 years ago, I said we put in this glass washer heat recovery project, and it saved water and it saved gas. So this is the wastewater that comes out of that system. And even though we've eliminated all of the tempering from that process, we still get about 3,000 to 5,000 gallons every day of wastewater coming through this, and this just flows to drain. So about 2 years ago, what we did is we said, well, this is actually fairly good clean water. Why don't we use it for another purpose before we throw it away? So this is our water reuse project, and we have a pre-wash function that's nearby that uses about 2,500 gallons every day of city water for this pre-wash. And so we thought, well, this would be a good application for this wastewater here. And so what we did is we built this tank, which is basically a wide spot in the system. And so this wastewater goes into this tank. Inside this tank is a float. And anytime these other storage tanks that we hold this wastewater in are not full, and this is full of some wastewater in here, then that pump operates to send this water over to a pair of tanks that we use for the pre-wash function. So while we're here, I'll show you one of the things that we added. Now this is about a 2-year-old installation, but about 6 months ago we added a water treatment system to a liquid bromine water treatment system so that we could control any potential biological hazards in our storage tanks. So this is something that we've added as kind of a lesson learned.
These are our two 1,100 gallon each water storage tanks for our water reuse project. We have two pumps here with variable speed drives, really a primary and a standby that we use. They're about 1 horsepower each. They pump the water up at about 60 pounds pressure up to this water pre-wash station. And note that we have instrumentation here such as flow control valves. We have a rotometer so that we know how many GPM we have going at any time, and this does fluctuate. We also have a water meter here that tells us how much water that we're using every day. We do have a backup city water system in the event that they might run this operation on a weekend when no reclaimed water is available. So we have a city water backup in that case, but it's rarely if ever used. Over on the tank side, what we do is we have a ultrasonic level sensor that maintains the level control in the tank. So what we do is we try to maximize the amount of reclaimed water or free water that we use for this system. And then if it ever gets down to a very low level that would starve the pumps, then the city water would come on. But when the city water comes on, it'll only come on to raise the tank level about a foot. It won't fill it entirely. So that minimizes the potential of using or overusing city water. Okay, this is another source of water that we've added for our water reuse project. What we're doing is taking the reject water from the reverse osmosis system, the production system. The RO system, when it produces about a gallon of RO water, it at the same time will waste about a half a gallon of water. So previously that water went to drain. So what we're doing here in this process here, we're taking the reject water, instead of going to drain, we're piping it over to our water reuse storage tanks. And those tanks provide water for the pre-wash function that we mentioned earlier. This is our groundwater irrigation system that's been in place for about 6 years. The source of this water is the perimeter drain system around our parking garages that continuously captures groundwater. So instead of pumping this to the stormwater system as is normally done, we capture a portion of this water and we use it for irrigation in the summertime. You can see here we have a pump system that pressurizes the irrigation piping and a control system that controls the level control in the tanks. So this is what we have here are two 1,100 gallon tanks. Now, 6 years ago when we put the system in, we only had one tank, but over the life of the system, we learned that we actually needed to capture more water to do all of the irrigation that we needed to do. So we put in a second 1,100 gallon tank. We didn't quite have enough water to do 100% of the watering, so we put in a backup city water system and a controller that would first try to use the groundwater for the watering, and then if the tanks got very low, then it would add a small amount of city water. So in the end, we found that for every 30 days of watering that we do, there's about 1 day of watering that we need to use city water for.
We're really proud of the results that we've had in our water conservation efforts. Since 1999, our campus has more than doubled in square footage, and we've been able to, over that same period, reduce our total water use by nearly 1/3. We've been looking at our Seattle Public Utilities top 50 customers, and in the year 2000 we used to be the 13th largest user, and as of our most recent records in 2009, we're now the 36th highest user of water in their service territory. So we're really proud of that, and we'd really kind of like to get off their top 50 list altogether if we can.